Water, liquid actually, exists everywhere around us. It is what maintains the life of human and the life of all creatures on Earth. But have you ever wondered, how does a splash of water disappear straightly from your sight? And what is the significant fundamental process that builds up the Earth's precipitation cycle? To understand this process, we first need to know, what is vaporization? Vaporization is the conversion of a substance from the liquid into gaseous phase. According to the definition by Britannica, they also categorized sublimation into vaporization, which refers to the conversion from the solid to gaseous state. But this will not be reviewed in this video. Vaporization can be further separated into evaporation and boiling. But what are the differences between evaporation and boiling? However, to understand the difference, we must understand another question. Why does liquid turn to gas? One of the assumptions by the ideal gas model suggests that gas molecules move in random directions with different speed following a normal distribution pattern. In other words, they have different amounts of kinetic energy following a normal distribution pattern. Liquid is in fact relatively similar to gas, which not all the water molecules have the same kinetic energy. Few of the water molecules actually gain enough kinetic energy and can manage themselves to escape and turn into gas molecules. Though there is restriction, which is they can't escape anywhere they want. Their kinetic energy often does not allow them to push other molecules away, including water molecules. So, normally, the only way to escape is to stay next to gas molecules, which is on the surface of water. Now the water molecules with high kinetic energy are gone, but notice that temperature dropped in the water they escape from, because temperature refers to the average kinetic energy, and it is the water molecules with the highest kinetic energy that managed to escape. However, the surrounding of the water immediately starts a mixture process, since the temperature is lower now in the water, the higher in the surrounding. After a period of time, they reached a new equilibrium. Water gains more kinetic energy, and water molecules gains the energy to escape again. This process occurs again and again, and finally forms a cycle. And this process is called evaporation, which water molecules escape into gas. There are several factors that can influence the process of evaporation. They are air pressure, humidity, wind, surface area of water, and temperature. Air pressure is negatively correlated with the rate of evaporation, because water molecules will now require more kinetic energy to break through the resistance. Humidity is also negatively correlated with the rate of evaporation. Remember why water molecules can only evaporate on the surface? Because they often do not have the kinetic energy to push a lot of water molecules out of the way. Similarly, the more the water molecules exist in the air, the harder the water molecules can escape. Wind speed is positively correlated with the rate of evaporation, because as the water molecules escape, there is a possibility of it being pushed back to the water resulting from the collision with air molecules. In this case, faster wind speed means that water molecules can leave much faster and fluently. Surface area is positively correlated with the rate of evaporation, because water evaporation from the surface. The bigger the surface, the more amount of water molecules can manage to escape. Finally, temperature is positively correlated with the rate of evaporation, since higher temperature means more kinetic energy. The more kinetic energy, the more the amount of water molecules can manage to escape. Having that in mind, a strange phenomenon can now be explained. What if the temperature is high enough so that water molecules can push away other water molecules and turn straight into gas without contacting the air? Then, the process now becomes what we call boiling, which for water molecules, it is at 100 degrees Celsius, 333.15 degrees Kelvin. When reaching this temperature, water molecules can be averagely provided kinetic energy that it is enough for them to push others out of the way and escape to gaseous state. This is filmed when pouring water at boiling temperature into a glass beaker. Pay attention to the bubbles